All right. Good afternoon. Happy Friday, everybody. Justin, what's shaking, man?
Happy Friday. Yeah, what a great week. Yeah, we've the last 2 weeks even. I mean, we've been just hard at work over here trying to be able to put some great new features in. We got a lot to talk about today. It's a really neat demo that we've got on shipping some apps. I'm excited. How about you? What's going on with you?
Oh, just it's football opening weekend, so that is the like
Technically, it
the
happened
newest one.
yesterday.
Oh
See,
yeah, yeah. Maybe.
I'm out in Philly. I watched that game, and that what a rocky start to the season. So yeah.
Yeah. I did not pay attention to the Phillies, but Titans had the first round pick, and so we are the underdogs of the year. And I am my goal is to bet $100 on every game and come out at least even. So fingers crossed. We'll see how it goes. But
Nice.
nobody cares about my home team. Very few people actually do. But excited to jump in and talk a little bit more about what we've been up to lately. And before we do, Justin, we've got a couple conferences coming up this fall. Where can people see us?
Yeah, we're going to be at the Microtech Electronics Show in London. That's going to be at the towards the end of this month, somewhere like the 25th, 26th, I think, somewhere in there.
Yep.
We'll have a table. Come see us if you're in London. That'll be cool. We'll have some devices with us, and we'll be doing some other neat demos there. Working on some pretty big brand hardware like Qualcomm, Nvidia, stuff like that. And we're also going to be going to Embedded World North America, and that's going to be a lot of fun.
Yeah.
We
Yeah.
were at the one Embedded World in Europe. I'm excited. This is like now the second one, right? I think that they're doing,
Yeah,
right?
second one in America. It's in Anaheim. So wear your Mickey ears or mini ears, depending on your preference.
Going to
At least,
Disneyland.
yeah, Disneyland, hardware, and Disneyland. Yeah. Well, cool. Well, let's get into it. You mind pulling up the slides? Tell people what we're up to today.
Absolutely.
Cool. So, welcome to the show, everybody. We're doing these bi-weekly live streams, building in public. Excited to show you all more interesting and exciting work on the Seed Studio reTerminal. My name is Will Brock, CEO of Peridio. Here we also have Justin, our Chief Product Officer. And with Avocado OS, we have a simplified production grade Linux story. And folks can ship apps, do R&D, and then also launch to production on the same unified stack. So let's get into it.
Cool.
So integrator's dilemma. So a lot of silicon manufacturers, SBC vendors, they're sending Ubuntu out built with these early stage devices. And Ubuntu and Debian is a very nice tool for early stage R&D and showing a POC. However, when you go to production, as many people know, custom OS is the route of preference. You're able to get a footprint optimized OS, bringing in only the peripherals, drivers, support that you need. And also, you are able to have exact reproducibility in the field that is not really possible on Debian based systems, especially if you're doing package management in the field. So, for better or worse, most embedded products require the creation of a custom OS to be production ready. And there's some real drawbacks to that approach in practice. So let's go to the next slide.
Oh no, I think we may have lost Bill. Oh, my network.
I'm having some delays on my side. I'm not sure if that's just me.
Looks like I might be having a few network problems on my side.
Oh, man. I'm having some technical issues here. Okay. I think we had a glitch on our, so OBS sharing is hard and we have a private comm so that we can talk directly. So excuse any glitches there. Getting back to it. So Justin, could you go to the next slide really quick? Let's talk about going to production on custom OS.
There we go.
Yeah. So Justin, what's going on here? What happens when you need to build out a custom OS for your embedded product?
It usually comes down to, building out custom stuff. You're going to reach for a tool like your like Yocto or like Build Group, but in these days, like Yocto is really becoming a great front runner in this. It's got wonderful support for allowing silicon vendors and some manufacturers, integrators to be able to extend forward everything that's necessary for their product to be able to get built, but at the cost of complexity. And usually, what that means is that the systems themselves, they take a very long time to build. They take a lot of resources. You need a real big amount of compute power to be able to do it. They're usually not very CI/CD traditional developer workflow kind of feeling. That really slows things down in getting things out to market. Usually, then application developers are kind of beholden to systems integrators when it comes to trying to be able to get their code into devices so that they can test. And that means that if you're trying to be able to be nimble and quick, then that can really kind of slow some things down. And in addition, not everybody has the kind of talent that's necessary on board to be able to maintain a system, a complex system like Yocto. Even though you can kind of build the world and you can have all your opinions, moving from version to version can be complex, and sometimes it can even be quite challenging or result in a lot of legacy. And with the Cyber Resiliency Act and the need for us to be able to produce more updates more frequently so that our devices can be more secure and that consumers can be protected. That can really be a hindrance then too when it comes to long-term maintainability for these things, increasing costs and really reducing the scalability of these kinds of approaches.
So we're here today to talk about the marrying of the best of both worlds. So go to the next slide. Yeah, so with Avocado Linux and Peridio, we have developer first workflows. We're really optimizing for the application development experience on the edge. And we have a very flexible architecture, and we work with a lot of different SOCs to where we have a production ready foundation for them to build against. On that topic of production ready, it also is immediately backs turnkey integration with Peridio Core so that you can have fleet observability, remote updates, secure remote access, things like that. And then again, to the partner ecosystem, we're supporting a lot of SOCs. Our primary focus right now is twofold. So we're picking a lot of the Edge AI enabled SOCs, so NVIDIA Jetson, Qualcomm 6490, a lot of conversations with Renesas on some of their chips as well. And then also the production ready targets. And so we have a few camera examples where you can buy them today. Go ahead and get started developing AI models, AI applications for things that you can deploy in weeks, not years. And then nice segue to the HMI that we're really excited about, continuing to use the Seed Studio reTerminal and reTerminal DM for showing what a day in the life looks like and having like UI changes and all of that and on a production ready foundation. So I guess we could go to the next slide, touch on a couple of the points here. So we have a containerized SDK, which is really nice. So you can use that to build your application code for these devices. We're going to be demonstrating that today. Additionally, we also have pre-built package feeds and system extensions. And so the pre-built package feeds are really nice. Justin showed this last week about bringing in, what was the tool we showed? Like TCP info? Is that a
Yeah, it was
TCP?
TCP dump. Yeah, TCP dump. Yeah.
TCP dump. And so we like pre-build a lot of these common utilities so that you can include them into your applications. But also we provide complete end-to-end system extensions that are already purpose-built for certain use cases. And what that gives our customers are reference templates and examples so they can get started working directly on the camel pipelines, the ML model updates, durable OTA, or even the HMI development itself. And so following this webinar, you'll be able to go into docs.peridio.com, download the examples and start shipping Elixir code, Python code, Rust code to a custom device out of the box. One more point, and we talked a little bit about the needs of a custom OS. Everything that we do sits on top of a very minimal runtime. And so we're exposing only the core Linux capabilities that you need for your device. And you can bring in as much as you want. And so like the Debian world, these are very, very large runtimes. Ubuntu supports everything, and they're awesome for this, right? Everybody relies on their package feeds. But an embedded, you only want exactly what you need to run. And so we make the ability for developers to pick and choose those integrations themselves very easy. So with that, Justin, let's show some code. Let's do it. 10 minutes in.
Awesome. Yeah.
Gold.
Yeah, so we did some cover a bunch of the getting started stuff. We're going to run through and take a peek at kind of like what it looks like for some of the new project templates that we have in this case. And so we'll see here that I've got code editor up that shows off one of our examples. You can check out our examples that we have for references over at the Avocado Linux GitHub org. It's at and this repository is at Avocado OS, and you'll see in the references folder that we have a bunch of different ones here that we're starting to be able to push even further on. There's some language options, and today what we're going to do is we're going to show off. Taking one of my old time favorite languages, and I still enjoy programming a lot in Elixir, and that's built on top of Erlang. And we're going to use that to create a Phoenix application that we can ship onto this reTerminal device as well. So we should be able to see here that we've got the smaller size reTerminal that we're going to be playing with a little bit today and programming up. And to get started, we'll just flip over to our terminal, and the first thing we're going to do with our project is export what target we're going to work with. So we're going to set avocado target to equal reTerminal. And then we can just do an avocado install. And I'm just going to pass the force flag here to be able to force it to install all of the package dependencies. And at this moment now, we're just going to pull down the SDK and the packages that we need for this application to run. So if I take a peek at the screen where we just were with this avocado config file, we're saying that we want to build this runtime. We're calling example Elixir, and it's got some dependencies. And we're bringing in the boot file images, the rootfs, and the initramfs. As Bill mentioned, we build all these to be as minimal as possible to just get the system to boot. And then everything else happens, including into the extension layer. So he mentioned that we pre-built some extensions to be able to make it easy to kind of plug in some new modular function. Like we have this Avocado X dev and SSHD, and we're bringing in one for WebKit as well. We'll see in a little bit how we can even customize those further. We also have a config extension and our example code, which today is really the fun and interesting part, where we're going to take this Elixir project here that we're bringing in as a submodule. We're just going to compile this into our application using our extensible SDK. So not only is the runtime extensible, as we were mentioning, to be able to make it so you can pick and choose what you want, but so is the SDK. And in this case, we're going to be able to install some components for Erlang. Back over to our terminal, we can see that the initial install was done. And this process may have took whatever the time it was for me to be able to talk there, maybe like a minute, right? And if we were to think about this in the sense of what it looks like to build in Yocto, figuring out what packages we need, enabling those functions, creating the recipes, and building over and over again could spend a lot of time there, hours, days, to be able to get up and running with those things. Here, we just installed all the packages directly from our repositories at build time, so we can start to be able to produce an actual running target with this. So back over to our example. Well, the next thing we're going to do is we're going to build this runtime, right? And to do that, we're going to bring in build all of these different extensions. We're also going to compile our code, and kind of here's what that looks like. You'll see in our config that we have these SDK compile blocks that you can add in. And with those, you can provide your own compile scripts. So in the case of this Elixir compile, we know that we just want to move into the directory. We want to set our environment and then run some Elixir commands using mix to fetch our dependencies, set up our assets, and release. The fun part about this is that Phoenix, the web framework for Elixir Lang, it brings in a lot of like JavaScript things. It uses ES script, and with our SDK here, when we compile these assets, we're actually in our controlled SDK environment going to be using the cross-compile ready versions of tools like Node.js and even Elixir and Erlang to produce this final runtime that's built for this device itself.
So essentially,
And
you have a full web application development framework ready built for this device.
yeah, and because Elixir actually uses Node.js to do a lot of the JavaScript compilation, if you strip away the Elixir and the Erlang from this, what you're really left with is the Node.js part of it. Any Node stack that you'd want, if you want to be able to do complete front end kind of single page app style stuff. It's really approachable and easy to be able to reach for. And as we demonstrated last week, we're just kind of marrying that together with our pre-built extension that automatically brings in WebKit for you. We just installed that as part of the installation process, and
Mhm.
WebKit alone can take hours and hours to be able to compile on itself.
So we're
Yeah,
not going to
so
vibe code today, but that is my dream. I want to vibe code Node video games on the reTerminal.
yeah, we're gonna have a separate series for build vibe codes video games on Avocado. That's gonna be great.
Yeah, unhinged hardware vibe coding. Yeah.
So when we take our SDK compile block that we build here, we're going to need to get it into our application. We're going to want to declare some additional dependencies that our SDK needs to extend it so that we can compile these things. When we bring in Erlang, Erlang has a lot of different apps, but we have explicit control over being able to select which ones are necessary to compile our stuff. That way it keeps the size of our tool chain pretty minimal. You're only installing what you really need. As we continue to move forward and make these helpful extensions, like we can see here, we're also just conveniently bringing in whatever the dev extension for us needs to extend our SDK. That's going to be tools like SSH and rsync to be able to handle side loading and desktop deployments directly to your devices. We are also going to wrap up common language stacks like this into easy to install ones as well. So you can choose to pick and select the individual components you need, or you can just kind of put down like the Erlang Elixir Avocado language extension as well.
Yeah, so the
So,
original intent was to run through like four of these. We're not going to do that today, but what are the ones that you have ready to go now?
well, yeah, let's get this thing to be able to do something. Let's render this Phoenix page. So if I do an Avocado build, that's going to start building the images, and you can see here we're running into an Elixir compile. This is happening in our SDK. We just produced a release there, just like that. And then the other extensions are being imaged and turned into images because Avocado, while it provides package management and extensibility at build time, it's an image-based runtime, and that's really important for us and embedded, right? So just like that, now we have our example Elixir application. And from here, we can use Avocado provision, and we'll provision using our USB provisioning profile. So if I take a peek on our unit here, as we mentioned on the back, you remove some components, but once you've done that, you can get to this little boot switch over here, and we'll flip that down to the provisioning mode. And I'm just going to plug in my device and apply some power to that. And that's going to take a moment to come up. While we do that, we'll run our provisioning script. That's going to abstract away kind of like the complexities that come with each one of these different targets to be able to provision it. You can see here, now we're shifting into being able to boot the device over USB. It waits for it to be able to appear as a mass storage device. This is just how the Raspberry Pi compute modules get programmed. They have built-in eMMC. And once this comes back up, it'll then show us that the device itself is ready to program. It's going to uh, identify that there's this new mass storage device that's available and kind of give us a little bit of a second chance to go, is this what you wanted? You know, for this device here, we're gonna say, there we go, 29 gigs. That's about right, 32, give or take a few. And now here we are writing the image to the compute module. I want to just focus a little once more and just shine the light back on the fact that, yeah, all these different targets have different ways to program them. Some use SD cards, some will use USB, and what we do is when we build the world, we also embrace all of the scripts and the tools that we receive from upstream vendors and partners that we work with, and conveniently package those into a way that normalizes it with our API. We call it Avocado Provision. Well, guess what? You provision all devices, but why do they have to be all these different magic words to say to them? We take care of that for you under the hood and make sure that the experience for these devices is, pretty much feels the same every time.
And so on our docs, as you go and look at the targets and the different production ready solutions, really the only difference is the provisioning step for each device. And then the application development workflow is entirely the same and unified, which is really cool. So the command even for provisioning is the same, but it's like, are you plugging in a USB? Are you swapping an SD card.
Yeah, yeah, exactly. Yeah. So in this case, we're just streaming all the bits down that wire, and this probably only going to take another moment to be able to finish up, and we'll be able to boot this device up, and we should see that pop up. In the meantime, I just want to peek back over to our config here and just take a look at what we're doing. We have added some additional new features. One of the ones that came out the last 2 weeks is the ability to officially pull in our shared extensions from the repository. You can do that with this version syntax up here. And also another one that you can see is, we're compiling everything into this example Elixir extension. We're building our app into that. Much like you have control over determining how the app gets compiled, you have the moment where you can choose and learn and take your assets and get them into the system extension as well. And from there, you have some explicit controls that you can put on that when that extension loads. We're saying things like this app we know is bringing in this service, and we want on merge to be able to just restart some other services that are on the device as well. So you have full control over adding your own custom commands when this extension merges with the system at the runtime, and also if you want to be able to automatically enable certain system D services as well. This is all done bringing the service file in through our overlay system. You can also reference as part of your source directory another place where you want to overlay part of the tree with that extension. So we're saying we want to bring in some changes to our WebKit extension. We want the cog URL to point locally to the server, Phoenix server that's running. And we're just going to include that Elixir service as well too. So really cool features on this one. It really rounds out the development experience, bringing in custom application code, being able to affect pre-built extensions conveniently. You need WebKit, just bring it in with Avocado X WebKit, and also to be able to have full control over your development and compilation environment as well.
So
And
where are we
so
at? Is this thing
we're
gonna ding?
provisioned. We're
Yeah,
provisioned.
cool.
All right, let's go back to our device. We're going to flip this guy here back into run mode and plug it back in. All right. And now what we'll see is we've got a little window here, and we slide this guy into view for us. Looks like I'm on the wrong one. I take a peek at my desktop. We got a window on the right that shows up our boot up sequence. So I've got a terminal directly into this as it continues to load up. But really, the star of the show is going to be when this device starts to boot. I see the screens coming up, and voila, there it is. We've got Phoenix
Okay.
running. Now,
Yeah.
the
So
cool thing, the
go
cool
ahead.
thing from here, I just want to point out is like there's a couple different features that we offer. Hardware in the loop development, for example, where we showed that a little bit last week, where you can mount this extension in and start to be able to iterate on it. What's really easy with that change that we have about if we look at the config file I was mentioning here, that we have these different ways to be able to extend the system, extend this extension with this overlay. And with this overlay, we're setting the URL. Well, if I just change this to maybe another location on my network, where on my development workstation, for example, I'm running the same Phoenix application, I can actually change it so that this is served, and I can be using rapid, development workflows where the code's automatically reloading on my workstation, and automatically it'll also be reloading on this target. So it's really quick. Another fast option in addition to hardware in the loop to be able to do these kinds of debugging experiences.
So we won't issue any code changes today, but what is really important to continue to call out, last week or 2 weeks ago, we showed WebKit pulling in an external URL, which was great. This is actually running the full-blown web stack on that device. And so this is like fully ready for customization. This example on the Phoenix Web Framework with pulling in like a Node Express server, some SPA, Flutter, that's all just following these exact same patterns.
Yeah. Yeah. And in addition, like we're tackling a lot of different languages in this case. Like if you have a call out on one of your favorites to be able to use, we can certainly bring those kinds of things in and make sure that the SDK is working on that kind of stuff. This references folder, you'll see there's an Elixir example, but we also have Rust example that we can compile in. This is with our SDK, similar layout as well as Python and Node.js. We have CMake examples too that you can use to be able to get C, C++ in as well. So maybe if you're a Fortran user, speak up and we can talk.
Some high
But
performance HMIs.
yeah, yeah. Yeah.
Awesome. Well, you want to anything else to share? We want to close out, pull through the rest of the slides really quick.
Yeah, I think that this really sets the stage for what's possible on bringing in custom application development code. I'm looking forward to being able to see where we go with this one next. But yeah, why don't we kind of see what's coming up down the line here?
Yeah, so this next piece, hold on the architecture really quick, and I just want to call out how we work is we partner with leading silicon vendors and we pull in their BSP, we work with their silicon, and then we provide the supported target like Justin was showing earlier. All the customers, users, developers get the experience of working against a unified application on top of that. And so if you're prototyping on Raspberry Pi and you want to move the Jetson, or if you want to move from Jetson to 6490, the developers have the same experience, which is incredibly nice. Now, of course, for some of the machine learning stuff, you're probably going to have some last mile like model tweaks and optimization, but that's incredibly quick compared to prior work of having to rebuild the entire Yocto stack from one target to the other. So if you want to just scroll really quickly, so we have quite a few targets we're supporting right now. Oh, yeah. So we'll land. We'll finish on join the community. Keep going through the targets. I'll talk to those really quick. So a lot of focus right now on NVIDIA Jetson, leveraging the NVIDIA Triton inference server. Super slick product, enables a lot of portability across different models against the NVIDIA runtime. Next on the list, I believe we had the Qualcomm 6490. So we're in the process of onboarding these devices right now. Rubik Pi, really, really cool SBC. And these chips are really, really high power. I think they have an integrated 12 tops on the integrated NPU, which is really slick. After this, we have the the ICAM 540. So this is an NVIDIA Advantech collaboration. We'll be showing this at the conference at the end of this month. And then our next series of chips are all IMX focused. So the IMX8, IMX8MP, 91, 93, and coming soon to a Mouser near you will be the 95. And we really love the NXP product line. They've got a fantastic base Linux, and we see a lot of like HMI applications and industrial use cases on the NXPs. If you are interested in working with us and supporting your silicon, there's really a three-stage approach. So we have integration, enablement, and then marketing and adoption. And so we take the work on to bring in the BSP. We then put together the target use cases, example products, and scenarios. Like somebody goes to a conference and they're like, hey, I want the HMI running that exact stack. You don't just hand them a bucket of Yocto work that they need to do. They're able to actually pull it in, quickly run Avocado OS, and get started on their application immediately. And then we go through a lot of scenarios like this, and then webinars, public events, etc., showing up in person and waving the flag and saying why our collaboration is fantastic.
Yeah, our partners really love the ideas that there's a big gap where there's frameworks and there's tools that are out there that just really make it seem like it focuses a lot on the development experience, dev tools, dev kits, and it feels really developer centric in those cases. And that's great. Developers need good tools to be able to move quickly. But we love to be able to approach these things where we have a production ready target that's ready to go from
Yeah.
the development experience. And our partners really love that aspect of it as well too. So
All right. So let's scroll back up really quick. Tell people how to get involved. Why don't you run through this, Justin?
yeah, so you can join us on Discord. We're the cool kids, I guess. Running on the Discord channels. Check out the link there to be able to get in and get into the conversations. We're always kind of like monitoring that, and we'd love to be able to talk about all types of things, avocados. So check us out on GitHub. That's where you can find a lot of the source, and we have a wonderful documentation center. It's been put together with the docs continually getting better and better on the daily. And reach out to us on Peridio and learn more about everything. We'd love to be able to have smart conversations with wonderful, smart people like yourselves. So it's exciting to be able to get time to be able to hear your problems, your pains, how you're working with things, and solutions that we might have to help you out and solve them.
Yeah, let's talk about Linux.
Yeah, exactly.
All right. Well, thanks, Justin, for the awesome demo today. Thank you, everybody, for joining. And yeah, please reach out if you want to learn more. And we look forward to seeing you all in the next one.
Thanks, everyone.